Alright folks, let's go over what happens with our angle pair relationships and when we have parallel lines. It's very simple, very basic, very straightforward. First off, corresponding angles. We learned last section what corresponding angles are. Now, if my lines are parallel, simply corresponding angles are congruent. So you can see here in this diagram, angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, 5 is congruent to 7, and 6 is congruent to 8. Now notice, all of the red angles, they're all the same, and all the blue angles are all the same. So when we solve for angles in parallel lines, you essentially have two different angle measurements. Notice, alternate interior angles are also congruent. So 1 is congruent to 3, and angle 2 is congruent to angle 4. Consecutive interior angles are not congruent. They are supplementary. Now, if you recall back in the last section, I had a different name for consecutive interior angles. What did I call them? Who remembers? I called them Now, why did I prefer the name same side interior angles? Because, simply put, if you have same side interior angles, they are supplementary. Look at the S's. Same side supplementary. So that's the easiest way to remember these. Same side interior angles are supplementary. Scrolling through here now, alternate exterior angles are also congruent. So angle 5 is congruent to angle 7, and angle 6 is congruent to angle 8. Now, none of the books that I've ever used ever mention these, but these do pop up sometimes. These do exist. My cat box. There we go. Same side exterior angles. They do exist. Not many books reference them, but same side exterior angles have the same property as same side interior. They are supplementary. This is a pretty basic and straightforward theorem right here. If line A and line B are both parallel, as you can see, parallel, and line A is perpendicular to line T, then line B must also be perpendicular to line T. Look at the angles they have marked. Those are corresponding angles. So if they're both 90 degrees, that means they're perpendicular. Now we're going to go ahead and we're going to look at some examples. Don't worry, you get to see my beautiful face in just a few seconds here. So, starting with example 1, which I drew right here on this board. The question simply asks, what other angles are also 125 degrees? Well, we just learned our angle pair relationships. So, here is 125 degrees. 125 degrees corresponds to angle 7. Since we just learned corresponding angles are congruent, angle 7 is also 125 degrees. We also learned that alternate interior angles are congruent. So what is alternate interior to the 125? That would be angle 5. So angle 5 is also 125 degrees. Angle 5 now corresponds to angle 1. So angle 1 is also 125 degrees. Now the question does not ask, but what would be the measure of the other 4 unknown angles? Since 125 degrees and angle 2 form a linear pair, simply take 180 minus 125, and angle 2 is now 55 degrees. Angle 2 corresponds to angle 6. So angle 6 is also 55 degrees. Angle 6 is alternate interior to angle 4, so angle 4 is 55 degrees. And angle 4 corresponds to angle 8. So angle 8 is also 55 degrees. Notice when you have just two parallel lines cut by one transversal, you literally only have two different angle measures. Four of them in this example are 125 degrees, and the other four are 55 degrees. Now let's take a look at example 2. Find the value of x. Now, we can only find the value of x because of one reason. We know that line R is parallel to line S because of the arrows. So, since these lines are parallel, the first step you do is identify what kind of angles are the 113 and the 3x minus 4. What angle pair relationships are they? They are alternate exterior angles. What do we know about alternate exterior angles? They are what? Congruent. So we can set up our algebra problem. 3x minus 4 equals 113. Once again, the algebra or the geometry is done. It's a matter of solving the algebra. Add 4 to both sides. So 3x equals 117. And then divide both sides by 3. X equals 39. Now let's look at the last two problems on the bottom of the page. The first one, the sketch, looks like this. Find the values of x and y. To do this, we're going to use the angle pair relationships that we already know and move from there. For example, see where the 110 degrees is? The 110 degrees is a corresponding angle to angle x. So if this is 110 degrees, x is also 110 degrees. Now that I know x, I see that the relationship between x and y are alternate interior angles. We know that alternate interior angles are also congruent. So y is also 110 degrees. Look at the problem right next to that. Very similar. Again, find the values of both x and y. Well, once again, the 106 degrees is corresponding to angle x. So x is also 106 degrees. Now, x and y have no relationship. So let's look at y and 106 degrees. What kind of angle pairs are those? This is back from chapter 1. They are a linear pair. Together they make 180 degrees. So 180 minus 106 will get you angle y. 180 minus 106, 74. So y is 74 degrees. So we have two more examples on solving for x when dealing with parallel lines. And then we're going to do something that's everybody's favorite. The next example, please excuse my crude drawings. Solve for x. So once again, the first thing you want to do is identify what angle pair relationship are they. What is the relationship between these two angle pairs? They are alternate interior angles. If they are alternate interior angles, they are what to each other? Congruent. So, x plus 15 equals 80. Very simple algebra problem. Subtract 15 from both sides and you're done. So x equals 65. The problem right beneath that looks like this. Now again, step 1, identify the angle pair relationships. 2x degrees and 68 degrees are now consecutive interior angles. In section 3.1, I briefly stated that I don't like the name consecutive interior angles. I prefer the name same side interior angles. The reason I prefer to name same side interior angles is because it's very easy to remember which angles are congruent and which ones are supplementary. Same side interior angles are the only ones that are supplementary. So if I stick with the S's, it's very easy to distinguish between all my angle pair relationships. Same side are supplementary. So, supplementary, again, what does that mean? It means they add to 180. So 2x plus 68 equals 180. Solve. Subtract 68 from both sides. I'm left with 2x equals 112. Divide by 2. X equals 56. Okay, let's take a throwback to chapter 2 and everyone's favorite. Proofs. Given that P is perpendicular to line Q and line Q is parallel to line R, I want to prove that line P is in fact perpendicular to line R. Let's take a look here. Statement 1. Right here. P is perpendicular to Q. Why is P perpendicular to Q? That is given. I just lost my word. Right here, folks. P is perpendicular to Q. Now notice they didn't say Q is parallel to R, so I might use that word given again later. Statement 2. Angle 1 is a right angle. Why is angle 1 a right angle? Looking back at statement 1, I said lines were perpendicular, so therefore as by definition of perpendicular. So if angle 1 is a right angle, moving on to statement 3, angle 1 is 90 degrees. So if 1 is a right angle, that means it's 90 degrees. Well, if that means its definition of a right angle. Q is parallel to R. There it is. Look right here, folks. Q is parallel to R. There's my other given that we weren't told before. So I get to use that word again. If I knew how to type. Now, since I know Q is parallel to R, look at the diagram. Q is parallel to R. This is line Q, by the way. Line Q is parallel to line R. Well, if line Q is parallel to line R, what kind of angles are angle 1 and angle 2? They're congruent because they are corresponding angles. If angle 1 is congruent to angle 2, that means angle 1 equals angle 2. That's the definition of congruent. Now this is the one where some people get confused one with the other. The measure of angle 2 equals the measure of 90 degrees. Well, angle 2, looking back at the previous statement, also equals angle 1. And then going back up to statement 3, angle 1 equals 90 degrees. So if angle 1 equals 90 degrees and angle 1 equals angle 2 must equal 90 degrees. That is technically the transitive property. So if 2 is 90 degrees, That means 2 is a right angle. So that is definition of a right angle. Since now angle 2 is a right angle, look where angle 2 is. If 2 is a right angle, that means line P is perpendicular to line R, and that is the definition of perpendicular. There you go, folks. There's your proof using parallel lines. Okay, I only got a few minutes to talk about this. Lesson 3.5. I have it tied in with lesson 3.2. My kids are taking a nap, so we got to get through this quickly. Listen, 3.5 is just like 3.2. The difference, 3.2 says if the lines are parallel, solve for the variable. 3.5 says what is the value of the variable that will make the lines parallel. So we want to make the lines parallel. 3.2, they gave us parallel lines. 3.5, they want us to make them parallel by finding the correct value of x. So we're going to set these up exact same way we did with lesson 3.2. So I have here 11x minus 25, and here I have 7x plus 35. What kind of angle pairs are these? We set them up the same way. These are alternate exterior angles. So we know that alternate exterior angles are in fact congruent. So we set them equal to each other. So 7x plus 35 equals 11x minus 25. Okay, geometry's over. This is algebra. You know how to do this. Solve for the variable. Subtract 7x from both sides. Add 25 to the other side. 35 plus 25? 60. Divide by 4. Now, they didn't say solve just for the variable. They said, what is angle ZYN? So we have to plug it back in. 7 times 15 105 plus 35, and the angle comes out to, so our final answer is 140 degrees. Shh, they're still sleeping. You can still check your work. You can plug it in up here. You should get the same answer. 11 times 15. $165 minus 25. 140 degrees. They came out equal. We did it correct. I gotta go. False alarm. Still asleep. Which means we have time for one more problem. The last problem in the notes. Same principle. First identify what angle pair are they. Notice where the arrows are pointing. This angle and this angle. What kind are they? They are alternate exterior angles. So alternate exterior angles are congruent. So set them equal to each other. 9x minus 21 equals 7x minus 3. Set it up, solve it. It's just algebra, folks. 2x equals, add 21, negative 3 plus 21. Watch your positive negative numbers. Divide by 2. Get x equals 9. Again, you can check your work, plug it in, and see if they come out equal. It should. I know what I'm talking about. All right, nap time's over. Gotta go.